2.5, complex zeros. And the fundamental theorem. Of algebra. Alright, so these say to write the polynomial in standard form and identify the zeros of the function and the x-intercept of its graph. So, number 2, f of x equals x plus 2 times x minus the square root of 3i times x plus the square root of 3i. So I think I pointed out in the video, but if you are told that I is a 0, then negative I is also a 0. Okay, so in any combination of that. So the reason that these are like this is because you would have been told, okay, negative 3i, so then you would have known that positive 3i would have also had to be 1. So, all right, so we're going to start out by multiplying. So what is this?
It's a difference of squares.
Difference of squares, so what is that going to multiply into?
X squared equals, not equals, x squared minus square root of 3i squared. Wait, that doesn't make, no, 3i squared.
So when you have square root times the square roots cancel and you just copy down what's inside. And then I squared is what?
Negative I.
Negative 1.
Negative 1. So this is going to become plus 3. So we've got x plus 2 times x squared plus 3. Then what do you have?
You got x cubed plus 2x squared plus 3x plus 6.
Great. And that's in standard form. So that's the first part of what it wants.
Wait, that's not really the first part.
Yeah.
But no.
It also wants zeros.
Okay.
So for the zeros, we just take each piece and set it equal to 0. So x plus 2 equals 0, x minus the square root of 3i equals 0, and x plus the square root of 3i equals 0. So we have that x equals negative 2, x equals the square root of 3i, x equals minus the square root of 3i. So those are my zeros. And then it also wants the x-intercepts. So that's just where it's crossing at a 0. So that's just x is equal to negative 2 is the x-intercept. I'm the most concerned about you getting your zeros and then the standard form of it.
So the x-intercept is just gonna be the one that's not in
The one that doesn't have the I with it. Because the x-intercept has to be something that's real. So. All right, the next ones, it says to write a polynomial function of minimum degree in standard form with real coefficients whose zeros include those listed. So something like number 8, you're told that the zeros are negative 4, 1 minus I, and 1 plus I. So they could have only given you the first two, and you would have had to know that 1 plus I was also going to be 1.
Okay.
Okay, because of the rule that comes from that. So you're told that these are the zeros. Okay, so that tells you that you have x is equal to -4, x is equal to 1 minus I, and x is equal to 1 plus I. We want it in standard form, so we need to get all of these things like moved over, okay, to get our factors that we can then multiply. So x plus 4 equals 0, so that's going to be one of my factors. X minus 1 plus I equals 0, and x minus 1 minus I equals 0. So those are my three factors that are going to get multiplied by each other. So I have x plus 4 times x minus 1 plus I times x minus 1 minus I. So then you need to multiply through. I would probably do these two first and then do the x plus 4 last. Not that it matters, but I just think it might make it a little bit easier. So if I multiply these two first, what do I get? I'm going to copy down the x plus 4 so I don't forget about it, but
I lost myself.
you've done the first one all the way across, so you're on -1.
Okay. Then minus x. And plus 1. And then minus.
Plus.
Is that plus 1?
No, and then the next one.
The next one is also plus. -1 times -I.
Plus
All right, now you're on the I term all the way across.
Oh, I was doing the other one. I don't know, I'm making myself. And then plus 1x, I mean ix, not 1x. Minus I mean, yeah.
What? Where are you?
I don't know.
Oh, okay.
It was plus ix minus I squared.
That's okay, Josh. You got halfway there.
And then I'm going to go through and cancel some stuff out to make my life easier.
Cancel.
So minus ix and plus ix cancel, so I'm going to get rid of that.
What cancels?
Everything with an I, man.
Plus I and minus I cancel.
'Cause then the
Now negative I squared is going to become what?
plus 1.
This is going to become plus 1. So I'm just going to replace that. I'm going to slash it the other direction so that I know that it's now plus 1. So then when I go to simplify it to make my life easier, I've got x plus 4 times x squared minus 2x plus 2. So then I need to superfoil.
Okay. Somebody else say that.
You know what?
No, I don't think I do.
Josh, you did awesome.
Oh, amazing.
Stop lying.
Okay, so then it's gonna be x cubed minus 2x squared plus 2x plus 4x squared minus 8x plus 8.
Mm-hmm.
Yep.
We're gonna simplify it.
Good
So
job,
it's gonna
baby.
be x cubed plus 2x squared minus 6x plus 8.
Beautiful. Do y'all need to see another one of those?
No, I don't think so.
If we do, I don't mind. If everybody's like, no, I got it.
Which one?
I think I understand.
Oh.
I understand.
Okay.
What about
I.
you, Kate?
It's really just the first part of setting it up. So it's always take the zeros that you're given.
No, it's
I always will write them first as x equals whatever, and then move it over, because when you get the stuff like this, like 1 minus I or 1 minus the square root of 3i, like that's going to get to be a lot, and so that way I make sure that I'm moving my signs over correctly, because you don't want to start out wrong.
Then the whole thing.
And then also that helps me to see if something is wrong from the beginning. I see, oh, you just didn't change your sign when you moved it over or whatever, because that can get confusing for some people. So once you have that, it's just normal foiling or super foiling or super foiling or, whatever.
I feel like boiling's easy. I like boiling.
Yeah, I like boiling. I like when it just comes down with boiling.
I agree.
I'm just like,
All right, write a polynomial function of minimum degree in standard form with real coefficients whose zeros and their multiplicities include those listed. So that was a lot. I'll explain it when I write it down.
What did they say?
-1 of multiplicity 3.
Was that a
Does that mean that they're 3 times, right?
Yes. And then 3 of multiplicity 1.
It's almost like how hydrogen is there.
Why am I so bad at spelling multiplicity?
It's a weird word.
That's it takes my brain so much longer to think about it. I'm like, wait.
I'm literally missing the most important part of chemistry.
Well, not the most important part. It's just
Like
resonance.
resonance. We're doing resonance today.
I don't even remember that.
It's with the Lewis structures and stuff. Where it
Yeah.
looks the same, but it's like upside down or
I'm
something.
gonna miss it.
All right, so we're writing a function, okay, with the given zeros, and the multiplicity is how many times. So it's just that when you write that parentheses, it's getting raised to that power. So we have x equals -1 and x equals 3. So my factors are x plus 1 and x minus 3. So f of x equals x plus 1, we're told multiplicity 3, so that means it's getting raised to the 3rd power, times x minus 3, it's only multiplicity 1, so we just have to write it. So then I would probably, to make it easier, write x plus 1 times x plus 1 times x plus 1 times x minus 3. And then what I do, personally, is I will FOIL these two together and these two together, and then I will super FOIL after that.
Yeah.
It just makes it easier than having to keep, it makes it shorter. So, so doing the x plus 1 times x plus 1, that's a special type. What is that?
X squared plus 2x plus 1.
Yep. It's a perfect square trinomial. Then x plus 1 times x minus 3.
X squared minus 3x plus x minus 3. Which is
Yep.
x squared minus 2x.
Oh wait, we have to put it in bracket.
It doesn't matter.
Oh.
I usually do if it's 3 things, just to...
What is that? What am I doing?
And then now you just gotta multiply, like the first one times all of them, second one times all of them, third one times all of them. So what do I get when I do that?
Okay.
X to the 4th minus 2x cubed plus 3x squared.
Minus.
Yep, that's what I'm at. Minus 3x squared. And then plus what?
Yep.
Oh.
Second term, first one.
Oh.
plus
Just
x
copy
squared
that
minus
stuff
2x
down.
minus 3.
Way to steal Nathan's spotlight, Josh.
So then to combine everything, we've got x to the fourth. I only have two cube terms that cancel each other out. Squared terms, I've got negative 7x plus x, so negative 6x squared. And then minus 8x minus 3. Is that what y'all got?
Probably.
Yeah.
Yeah. Yes, that is what I want.
All right, I'm going to set up the next one, but not actually do it. Number 16, got negative 1 with multiplicity 2. I'm just going to write MULT for multiplicity, just FYI, because I want to make it shorter. Then negative 2 minus I for multiplicity 1. Now, if these are the zeros, what do I need to have?
Negative 2 plus I.
Yep, negative 2 plus I also needs to be 1. And it's going to still just be multiplicity 1, just like that one.
Wait, why isn't it? Why does it have to be negative 2 plus I?
Because when you have a I as a 0, you've got to have its opposite as well.
Oh, is that
Oh, so we're
that's
just
one of the
adding
rules,
another
right?
0. Okay.
That's why I said sometimes they'll give them to you and sometimes they won't. So you have to look and make sure that they're both given to you. And just assume that the multiplicity is the same as whatever it was. Typically, they're only going to give you that as a multiplicity 1. But if for some reason it's different. So then I've got x equals negative 1, x equals negative 2 minus I, and x equals negative 2 plus I. So factors are x plus 1, x plus 2 plus I, and x plus 2 minus I are your factors. So I'm just setting it up.
Yeah, we're not gonna
Yeah, I'm not going to actually multiply this one out. X plus 1 is multiplicity 2, so it's squared. And then you've got x plus 2 plus I times x plus 2 minus I. And then obviously you would work it down from there, but I'm not going to because I think we seem to be okay with multiplying.
Well, yeah, I feel like the hardest part is getting it set up right.
Yeah.
Anyway.
Once they're set up, they're just like normal. So
I made a good crack today.
thought it looked like the door was about to open. I was like, what is going on?
Oh my gosh.
Say you, Josh.
That was me.
Whoa!
Are your hands?
That's my back.
They made that noise?
Yeah, that was my
Well,
hand.
she practiced.
Oh, I was like, something's
No.
wrong.
You got a good crack in his back though.
I was
didn't
like,
know
when I
my
go to the
back could do
chiropractor, it doesn't
that.
sound like that.
Guys, I didn't know my back could do that. It's crazy.
All right, state how many complex and real zeros the function has. So we're just saying how many of each it's going to have. So 22, we've got f of x equals x cubed minus 3x squared plus x plus 1.
Okay.
That's actually
That doesn't sound as loud, but
oh,
there we go.
Oh, yeah. Just a bunch of
Oh.
Are you serious? Josh, really?
That was funny though.
Sorry, I did not really.
I don't think he meant it like that.
No.
though.
No, we didn't like that, but it was
Just a bunch of
funny.
crackers. All right, Josh.
Okay.
Okay.
Does that mean there are gonna be 3 zeros, or is there gonna be more?
Well, the last-
There are. I was trying to remember.
I was gonna say, and then I was like,
Well, I'm
oh,
not a
just a
cracker.
bunch of crackers.
Yeah, that's better.
Yeah.
I have Asian. Is that like still making
Are you white?
No.
I'm
put
not white.
seeds on top or something.
Yeah.
Does everything crackers?
Whole wheat crackers with the everything bagel season on it. I'm just a Ritz.
Just a Ritz.
Or a saltine.
More like a saltine.
Yeah. No. I have some like pan. I like
I
the
like
Ritz.
I like the
Don't-
wheat thins.
Oh, I love wheat
Love
thins.
wheat
I want to be a
thins.
wheat thin.
What?
What is this talk?
I don't know. Oh, it's all recorded.
All right.
Okay.
Sorry.
I think we're just gonna do these by graphing is what I want to do.
Are they like weird?
Well, to see about the zeros, because it wants us to tell how many complex and real zeros the function has.
Oh. Are complex like the fake ones?
Well, so no, because this first problem doesn't make sense with what their answer is based on what you just asked me. That's why I'm like, wait a
Oh.
second.
Oh.
Complex would imply that it has i's in it.
Okay. I thought so. I wasn't sure.
But like for this first one, it says that there's complex, but they're all real.
That's not
I
how
think
that works.
that's possible.
That's not how that works.
So that's why I just said, hold on a second. Let me just graph it and see if it's obvious here because
Can you stop like
This is my
caressing
favorite
your
calculator.
calculator? You're like
This is my favorite calculator. This calculator has been through some
Josh is
stuff.
over here like
Stop. It's
You're
taking my case
doing
off.
that, John.
yeah, he was doing
Josh, you're doing that?
Bro, this has
I
been
was
through
taking my case
this
off.
has been through pharmacy school, undergrad, like this has been through a lot of trauma.
I used to, when I went to middle school, I used to take this calculator into the bathroom, and like when I was late, I used to do my makeup in the screen of the calculator.
Why didn't you just use the mirror in the
Because I
bathroom?
was
That
too
sounds like the
embarrassed.
worst.
Because I was too embarrassed to do it in the mirror.
Sorry.
so when we're looking for zeros, we're looking at how many times it's crossing. Okay.
3 times. 4.
Oh, so I need
But the number of zeros should match the highest power that you have.
So we need to plug this in.
So you would just graph it in y equals, just
Okay.
like normal. And then you would see how many times is it crossing.
Okey doke.
So it's a cubic function.
So it should just cross through.
So yes, it should. Now, if you actually find the zeros, which you can using your calculator, but
3 times.
you're gonna have 3 real zeros.
How can you tell when they're complex?
Hold on. Oh. What do you mean?
Catch, dude.
Like, is there a way to tell on the calculator if they're complex or?
I'm
Will they show up?
hold on. I'm seeing if it will do it.
Yes. Yes.
We might just get rid of these problems because these are a little bit confusing, to be completely honest.
I don't like that book.
Oh my god.
Something just.
It was my knee. I keep doing it on accident. I have my foot pinned and I turn around.
Oh!
Oh, that's
Your-
not good.
Your meniscus is gonna be
Oh
gone.
my
girl.
gosh, bro. Stop it. Stop it.
My goodness.
Do you have any?
I did.
No.
I did both.
Not the
I just like
not the
saying that.
Medusa.
I think it's nothing.
All right, we're just gonna get rid of these problems because these are.
What?
I don't know. I thought Marco got it.
I'm pretty sure
Did you
Christine
get it?
said she got tested for meningitis the other day.
So
What?
Well, you get meningitis or no meningitis.
We're just gonna get rid of that problem. Just get rid of it. Just forget that it existed.
Okay.
That's what we're gonna do.
I really tried to
Imagine
cross
writing in
Imagine
pen.
writing in pen.
I wrote in
just
pen.
cross it out. I don't care.
I have to cross it out too, John.
No, I was writing in pen during chemistry yesterday, and she was like, oh, never mind, I messed this up. This supposed to go on this side.
I have the best whiteout there is.
I don't have any whiteout.
Oh, can I have that?
Should I buy
Like
whiteout?
forever.
No, no.
Like forever. I didn't even like.
It's just whiteout. It's awesome.
All right, so I think the way that they really want you to do those is the way that we're actually going to do the next problems, but it doesn't really make sense to do it anyways. We're going to just do the next problems that kind of incorporates that, but not in the same way. So these ones say to find all the zeros and write a linear factorization of the function.
Just go on a calculator.
Sort of. You remember what we were doing yesterday?
Yeah.
It's that, but with complex numbers now.
Okay.
Remember how I said, like, if you kept going, you'd factor it out and get complex zeros?
Oh, yeah.
We're doing that next step now.
I
Oh.
need to I need to invest in this. This is a good investment.
And sometimes you're going to have to use the quadratic formula.
Yay!
Sorry.
There's no yay.
What do you mean? There's no
Also, it's back up on the wall, everyone. No need to fear.
Yay.
Where?
Oh, I don't have to turn my head like 360
Oh, I see
degrees
it.
anymore.
It's not behind Christian's head anymore.
360 will be back at the place it started. That would be 180.
All right, so this is
Okay,
the
makes
equation.
sense.
Okay, so you're going to do it the same way we were finding the zeros the other day. The other day we were only finding the real zeros. Okay, now we're finding all of them. Okay, when it says the linear factorization, that just simply means rewrite the equation in factored form.
Is the 44 supposed to have an X behind it?
Yes it is. Yes it is.
Cookie
boy.
Sure. Why not?
Hey!
Nice, Peyton.
No.
I was just like, wait, you would simplify it.
I'm glad you noticed it because I don't think
Glad
anybody
you
else
noticed
did.
Because I was just thinking it would simplify it if it didn't have that.
All right, so we're going to do the factorization for 69 over 1. I'm okay without, like, you don't need to write the 1 since it's just a 1. You can just write the factors of 69. So,
Okay.
what are they?
1,
1. 69.
3.
Oh, I guess, yeah.
I was gonna say 9. No.
Well, 3 times what would give you 69?
Oh my gosh, my calculator's frozen.
23. And then 69.
Yep. So now you need to graph the function and see where it looks like it crosses.
Okay.
Oh, Josh, that was a little bit much.
You're a little bit much.
We know. I did. I really did.
It wouldn't be fun without much people.
Yeah, I'm glad you joined the class.
Me?
Yeah.
Thanks, guys. I'm glad I got a little exception.
Christian.
It's because I hate Bruno. It's okay.
Other than that, you're great.
Thanks.
Ooh,
It's a line.
it's on the.
What?
Are you sure it's a line? It's a cubic function.
Well, then I can't see the whole thing.
Yeah.
Okay.
Because it looks like a line.
And line. To the line.
Yeah, Josh.
All right, so where does it look like it crosses?
3.
Positive 3.
Positive 3.
Positive 3. So we're going to check that one first. So set up your synthetic. Remember, if any terms are missing, we got to put in a 0. None are missing, so we're good. 1, negative 10, 44, negative 69. And remember, it needs to be equal to 0 when we're done for it to be a factor. Or 0, whatever you want to call it.
Yo.
Bring down the 1. 1 times 3 is 3. Minus 10 is negative 7. Times 3 is negative 21. What's that, 23? Times 3 is 69. So, the factor x minus 3, so that's why I was writing them that way the other day.
Oh.
Okay, out to the side, and I'll usually circle them so that I can remember when I go back. Now, there was nowhere else that it looked like it crossed, right?
No,
There's
just
no
3.
else.
So, that's going to be your only real 0 then. We need to find the other complex ones. Okay. That's why I said in the last section you could have found them if you did it this way, but that's a lot of work for there to be a whole section dedicated to that later in the chapter. So, or in the section. So, Now, this was an x cubed term.
Now it's an x squared.
So now this is an x squared term. So you have x squared minus 7x plus 23 equals 0. Can I factor this? Are there
No.
factors of 23 that give me negative 7? No, there are not. So, quadratic formula, yay.
Oh.
So, negative b, so that's negative 7, so plus 7, or 7, plus or minus the square root of b squared, so that's 49, minus 4 times a times c, so that's 4 times 23, which is 92? 92? You're welcome to write it all out, I'm just
92.
trying to save space.
Yeah, that seems valid.
And then over 2a, so that's just over 2. So 7 plus or minus the square root of,
Negative 43.
thanks, negative 43 over 2. So if I have a negative under the radical, what do I have to do? Take it out. So 7 plus or minus I root 43 over 2.
That's all I got.
So I have, this gives me 2 factors here. Okay, I'm gonna have one that's,
Oh yeah.
well, let me rephrase. They're both, the whole thing is positive, but the sign inside is gonna be different. So you're gonna actually have to split them when you write these. Okay. So you'll have, as your factors, x minus 3 is 1, so f of x equals x minus 3. Then x, this whole thing would get moved over, so it's minus the whole thing, so minus 7 plus I root 43 over 2, and then the other one is x, again, the whole thing got moved, so minus 7 minus I root 43 over 2. So that would be the linear factorization that it's asking you for. It's just to write it like that.
Oh yeah, because it gets moved over to the.
Yeah.
It gets moved over to where?
Like this was like x equals this. So then to get the factor, I'm just moving the entire thing over to the other side.
We don't have to multiply that out.
No. If you multiplied it out,
Would it just get the top?
you'd get back to this.
Okay.
And that would be miserable to multiply.
That would just yeah.
I would end my life.
Well, don't do that.
Where's the bullet string?
Yeah, I'm ready for that balloon string.
All right, 34. Now this one says, instead of you having to find the zeros, okay, this one says, using the given 0, find all of it. So it's going to already give you one to start with, so you don't have to do this first step of writing them all out.
Amazing.
Great, amazing.
Amazing.
I love that.
So 34 gives you 4i as a 0. And then it says, well, of f of x equals x to the 4th plus 13x squared minus 48.
So if we know 4i is a 0, would that mean that negative 4i is a 0?
Yep, exactly. So negative 4i also has to be 1. So we're going to start out with one of them. Doesn't matter which one. Bless you.
Oh, it's not coming.
So we're going to start out with 4i. Okay, so this is a little different because now our synthetic has i's in it. You're going to do the same thing, it just has i's.
I have a
So numbers again get copied down, but keep in mind if something's missing, you got to fill it in. So I've got 1, 0, 13, 0, negative 48. And yesterday, I think it was Peyton that asked, but if the constant term is missing, you've also got to have a 0 for the constant term. Don't just assume that, oh, there's no x and, or the, there's just no constant. whatever, I don't need it. You have to put in a 0 for it to work, so. And just keep in mind, this is starting as an x to the 4th term, so when we simplify it down, it'll give us an x cubed term. All right, so we bring the 1 down, so then we do 1 times 4i
Which is 4i.
is 4i, plus 0 is 4i.
Then 16i squared.
So 16i squared would be
Then it's negative 16.
-16. So -16 plus 13 is
Negative
-3
3.
times 4i.
Is negative 12i.
So then -12i times 4i.
Is negative
48.
48i squared. So 48 positive 48.
So plus 48. So you verify that that's a 0. So if that's a 0, what is the factor?
X plus 4i.
That change sign.
Oh, minus 4i.
Yep, because remember, this is saying that like x is equal to that, so you've got to move it over to do the factor. So this is one of them. So then now, this is why I said yesterday you could use the simplified form if you were going to keep going, okay? Because when you get to these, you have to use the simplified form, or you will absolutely be miserable. So we're going to use this new one. So this was x to the 4th, so this is now x cubed. So I know that minus 4i also has to be 1, so I'm going to use minus 4i. And I'm going to copy down these numbers from here. So I've got x cubed. Well, here, let me rewrite it this way first. X cubed plus 4i squared minus 3, or wait, hold on. Brief pause. 4ix squared minus 3x minus 12i. So now I'm copying down the numbers with the i's with them. So 1, 4i, negative 3, negative 12. Now, I. Now, you don't have to rewrite it this way. I'm just doing it so you see where the terms are coming in right now. Okay, but you don't have to write. You could ignore this step if you wanted to. So then, follow the same procedures, bring down the 1. So that's minus 4i, which gives you 0, which gives you 0, then negative 3. Negative 3 times negative 4i is going to give you plus 12i, which gives you 0.
So x plus 4i.
So x plus 4i is a factor. So this was an x cubed term, meaning this is now an x squared term. So I have, there's no other zeros that I know were given to me, right? So I have now x squared minus 3 equals 0. So I need to find the other two factors. So x squared equals 3. Then x equals plus or minus the square root of 3. So I get two more factors from this. I get x minus the square root of 3 and x plus the square root of 3. So then you just have to write it out. F of x equals, so the first one was x minus 4i. Then I had x plus 4i. I had x minus the square root of 3 and x plus the square root of 3. We're just going to stop there. All right, I'm going to go ahead and tell you what your problems are. you'll have, I'm not going to give you homework over the weekend because I know there's just a lot. So, you'll have Monday to work on them. All right. So you need to do 1, 11, 15. Take me off that one. 29. 33. And 35. And if we need a refresher on Monday, we can do another one of the even ones as a refresher before you start doing your work.
Do